Hello. Here is an example using dice to calculate probabilities. So the question is let x be the sum of two dice. So x, capital letter X, that means it's a random variable. The sum of two dice, meaning we roll two dice and we add two dice together. Calculate the following probabilities. Okay, first question. The probability that x equals 9. In other words, what is the probability that you roll two dice and you end up with a 9? So down here we have our sample space, um, and there's 36 outcomes altogether. So we already know on all these questions, the denominator is 36. All right, so there's 36 possible different combinations. If you just count them up, you see 36 possible outcomes. Now, out of those 36 outcomes, how many ways can you get 9? Well, here's one. 6 and 3, that'll give you 9. 5 and 4 gives you 9. 4 and 5. 5 and 4. And 6 and 3. So that's one, two, three, 4 ways to get 9. And that's all. 4 out of 36. So the probability is 4 out of 36. Now, if you want to, you can reduce the fraction. Both of these numbers, 4 and 36, I can divide by 4. By the way, it's fine to leave the answer like that. And it's nice. There's a lot of advantages in probability to just leaving your fractions un, unreduced because then you know exactly the number in your sample space. But anyway, if you feel like reducing it, you can divide top and bottom by 4, and that would give you 1 over 9. Okay, also if you want to, you can give the answer as a decimal. So just do top divided by bottom, 4 divided by 36. And on a calculator, let's just get a calculator out here. Calculator, let's get the simpler one here. Okay, 4 divided by 36. Or you could do 1 divided by 9, it's equivalent. Point one 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 one. Okay, that's a lovely number. Let's just round that off to like 0.111. All right. And you can also give the answer as a percentage. Just move that decimal point two places, or technically times by 100, 11.1%. Round it off. Okay, there's the answer to the first question. Probability that x is 9. All right, next question. What is the probability that x is greater than 6? Let's erase our previous circles here, so I've got a little bit of a cleaner set of dice here. Oh, it's taken a while to do this. All right. Anyway, let's get back to the question. Probability that x is greater than 6. So remember, that's the greater than sign right there. So in other words, x could be 7, or 8, or 9, or 10, anything up to 12. Okay, so what are all the combinations to get me any of those? Well, let's start with 7. How many ways can I get a 7? Here's a 7, 1 and 6. Here's a 7. Notice that the way the chart is set up, it always goes diagonally here. So all those are 7s. But I want to know probability that x is 6, greater than 6. So 7 or 8. Here's all the 8s. There's one. Here's another one. Here's another one. Another one. Those are all 8s. And then the 9s. And then the 10s. And the 11s and the 12s. Okay, that's all the ways that x can be greater than 7. How many ways is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so your answer is 21 out of 36. And again, if you want to convert it to decimal or percent, that's perfectly fine. Or reduce it. I'm just going to leave it right there. So there's the answer to the second question. Okay, third question. What is the probability that x is less than 5? Remember, this is the symbol for less than. And so you just think, well, what numbers are less than 5? Well, 4 and 3 and 2. So let's see here. Here's a 4. There's a 4. Double twos is a 4. There's a 4. This is 3, this is 3, this is 1. So that's 1, 2, 3, 4, 5, 6. Answer, 6 out of 36. Okay, last one. What is the probability that x is between 4 and 10? Technically, this is saying 4 is less than x, and x is less than 10. But if 4 is less than x, x could be like 5, 6, 7, 8, and 9, but it still has to be less than 10. So in other words, I'm looking for all the way, no, not 4 exactly. It's not a less than or equal to, it's just a less than sign there. So I'm looking for all the x's between 4 and 10. So that would be 5, 6, 7, 8, and 9. Okay, well, I've messed up my chart here. I'm gonna pause the video for a moment and get ourselves a new chart. Okay, so by the magic of video, I just made a new chart here. And so now, what are all the ways that x can be between 4 and 10? So 5, let's see, okay, here's a 5. Oop. Here's a 5, 1 and 4. Oop, what happened there? There we are. Okay, 1 and 4, that's a 5. There's a 5. Here's a 5. Here's a 5. Okay, and 6. There we go, all the 6s. And all the 7s. All the 8s. All the 9s. Okay, there's all the ways that x can be between 4 and 10. Now, I'm going to get clever here. Yes, I can just count up all those combinations that I circled, but why not make my life a little bit easier? Let's count all the ones that I didn't circle and then subtract from 36. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 ways to not get an x between 4 and 10. So 36 minus 12 is 24. Okay, so how many ways can I get a number from 5 to 9? Is 24. So 24 out of 36. Now, of course, you could have answered it the same by counting up all the circled ones, and you would get 24. But it's just a little trick. And that's it for some dice probabilities.